This time we're going to draw ethane. So again, we're going to count our valence electrons in the compound, and I see that I have 2 carbon atoms. Each one has 4 valence electrons, but I have 2 of them. So that gives me a total of 8 valence electrons. And I see that I actually have 6 hydrogen atoms now. So I'm going to multiply hydrogen's 1 valence electron by 6 to get 6 valence electrons from hydrogen. And then if I add those together, I will get a total of 14 valence electrons. That's my step number 1. Step number 2 is determining the central atom. So this one's a little bit trickier because we don't just have one atom of one type of element in this compound, but what we do have is significantly fewer carbons than hydrogens. And we also know that carbon is capable of making more bonds than hydrogen because carbon will satisfy the octet rule. Hydrogen only likes to have 2 valence electrons. So hydrogen can only ever make 1 bond. So I'm going to draw my carbons in my center. And then I'm going to draw all other atoms around those central atoms. So I've got 3 hydrogens on each carbon in this case. I'm going to draw hydrogen, hydrogen, hydrogen. And then I'm going to draw connecting bonds to these central atoms. My last step is to put all remaining electrons as lone pairs or double or triple bonds to satisfy the octet rule or the duet rule. Well, again, let's count our number of electrons that we have right now. So I see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm supposed to have 14. So I am 2 electrons away from getting to the total number of valence electrons I'm supposed to have in this compound. Well, that is a simple fix because I still have not connected these 2 central atoms. So all I'm going to do is just draw a connecting line and a connecting covalent bond between those 2 central atoms. And I now have 14 valence electrons. 2, 4, 6, 8, 10, 12, 14. So that is my Lewis structure for ethane, C2H6. So now let's talk about how we might draw this 3D structure of ethane. I'm going to take it 1 carbon at a time. So each carbon looks like this. It's got 3 hydrogens coming off of it. And it is bonded to the other carbon. So I'm going to draw that extra bond there. Okay, so if I were to draw this in 3D form, I would probably draw, this carbon-carbon bond still within the plane of the screen. And then I'm going to add some 3D structure to the other carbon, or to the hydrogens. So I'm going to keep 1 hydrogen within the plane of the paper because we are mimicking, if each carbon has 4 things sticking off of it, its steric number is 4. Then we are going to be mimicking this structure here, a tetrahedral structure. So that means I'm going to have two things coming off of the central carbon in the plane of the screen, and then I'm going to add a 3D shape to the other hydrogens. So this hydrogen is going away from you all. This hydrogen is coming towards you all. Now I'm going to do the exact same thing for the other carbon. So I'm going to have the hydrogen up top, also in the plane of the screen. And then I'm going to add a 3D element to those remaining hydrogens. So again, as a reminder, this is what our initial Lewis dot structure looked like. And I can see I've accounted for all the hydrogens and the carbons in that Lewis dot structure. And you can also see this happen in our molecular model. So we've got each carbon is in white, each hydrogen is in white and each carbon is in gray. So again, please feel free to rewind, pause, do whatever you need to do with this video to make sure you record everything that needs to be written down in your notes. And then I look forward to discussing this in class with you on Monday and Tuesday.